Hello dear student, we are continuing with the chapter 2 atomic structure, and in this atomic structure we will start with the limitation of Bohr's model. The Bohr's model fails to account for the finer details of the hydrogen atom spectrum observed. This model is also unable to explain the spectrum of the atoms other than hydrogen, and the Bohr's theory was not able to explain the Siemens effect and the Stark effect. And this model is not able to explain why the molecules are formed by the chemical bonds. So to remove these limitations, we are moving toward the quantum mechanical model of the atom, which deals with the two important development, which is your dual behavior of matter and the Heisenberg's uncertainty principle. So what is your dual behavior of matter? The de Broglie's propose that all material particles when in motion are associated with the wave, and the wavelength of these materials particles can be determined by the formula lambda is equal to h mv. So h is your Planck's constant, mv is the momentum of the particle, where m is the mass and v is the velocity, and lambda is your wave property. So de Broglie also proposed the wave characteristics of the material particle. Then there comes the uncertainty principle. Uncertainty principles mean it is not possible to find out the accurate position and velocity of the electrons of or any material particle at the same time. So these two points cannot be explained by the Bohr's model. Therefore, the Bohr's model fails to explain these points and it is rejected. Next one is your uncertainty principle, which one is having the formula as delta x into delta p equal to h upon 4 pi, where x is the distance, p is the momentum, and h is your Planck's constant, and pi is the numeral value. So we will going to do these numericals in our sessions. So the uncertainty principle importance is that it rules out existence of definite path or the trajectories of electrons and other similar particles. Hence they are replaced by the reason where the possibility of finding the electron is maximum, and the concept of orbit has been changed to orbital. The second thing is that the effect of Heisenberg's uncertainty principle is significant only for the motion of the microscopic objects and is negligible for the that of macroscopic objects. So a quantum mechanical model comes into access, which explains that the electrons are moving around the nucleus, not in a fixed path but in a fixed region, and this region is known as your orbital. So now the equation has been given in the form of waves, Gauss equation, and it is your h wave equal to e wave, where e is your energy and h is your mathematical operation called for Hamiltonian equations, and they gives the shape of the orbital. To provide the shape of the orbitals, we are having the different quantum number, and these are your principal quantum number, Azimuthal or the angular momentum quantum number, magnetic quantum number, or the spin quantum number. So now the first one is your quantum number for your principal quantum number, which is denoted by n, and this principal quantum number gives us the distance of the electron from the nucleus, and it's also give us the energy levels of that electrons. If n is 1, so this means the electron is present in the first energy level. If n is 2, it is present in the second energy level, and so on. The second one is your azimuthal quantum number, which is denoted by L. This quantum number indicate the subcell or the angular momentum of the electrons present in it in the energy level, and its values lies from 1 to n minus 1, and the specific shapes has been determined for the values of L. If L is 0, then it is S subcell. If L is 1, then it is your P subcell. If N value is 2, it is your D subcell, and if L value is 3, it is your F subcell. Then there comes the magnetic quantum number. This quantum number depends upon the L value, and it lies from minus L to plus L. It is denoted by M. So if L is equal to 1, the M value will be plus 1, 0 and minus 1. So this means P subcell has been divided into 3 orbitals. Similarly, D subcell has been divided into 5 orbitals. Next one is your spin quantum number. Spin quantum number tell me how the electron is moving or the spinning around it orbits. So if the electron is moving clockwise, then it is your plus half value, and if it is moving anti-clockwise, then it is your minus half value. And the two electrons which are present in an orbital will always move in an opposite spin. Like one is moving in a clockwise direction, the other one is moving in an anti-clockwise direction. There is a Pauli's exclusive principle which states that no two electrons can have the same set of 4 quantum number. Two electrons in the same orbital must have opposite spin. Here some given to you. If the value of n is 1, so the principal quantum number is 1, and the value of L is 0, so it is designed as 1s. 202s, 212p, 20, this one 303p, 31 your 3p, and 32 will be your 3d. Similarly, 40 will be your 4s, 41 will be your 4p, 42 will be your 4d, and 43 will be your 4f. Next is the shape of the orbital, and this shape is represented by the boundary surface diagram. The spherical shape is there for the s orbital. So here are the three s orbitals, 1s, 2s and 3s. In between them there is a region where the possibility of finding the electron is minimum, so it is known as nodal region. The shape of your p orbital is your dumbbell shape because it is the directional one. Each axis is having its own dumbbell shape. So if we are having pz, px and py orbitals in our p subcell. Next one is your d orbitals. They are dumbbell shape. dyz, dxz and dxy, they lies in between the axis, whereas dx square minus y square and dz square lies on the axis. Next one is your how to fill these electron in this orbit, which is governed by the three rules. First one is your Bohr principle. Second one is Pauli's exclusive principle. The third one is your Hund's rule of maximum multiplicity. Bohr principle states that the electrons will be filled from the ground state, and then the electrons will move to the higher energy orbitals. And according to this, there is a Bohr's rules also, Bohr-Boris rule, which indicates that n plus L rule. Lower the value of n plus L, lower will be the energy for that orbital. So here in this case 1s, 2s, then the electron will move to 2p, then the electron will 3s, then 3p, 4s, then 3d. So according to the Bohr-Boris rule, the n plus L rule for the 4s will be less than that of 3d. Therefore 4s is having lower energy than that of 3d. Then comes to be your Hund's rule of maximum multiplicity. He says that the pairing of electrons in an orbital will not take place until and unless all the orbitals of the same subcell is completely filled, singly filled. If they are occupied, then only the filling of the pairing of the electron will take place. One thing more here is that stability of the completely filled and half filled subcells means the completely filled and half filled subcells are more stable as comparison to the other filled orbitals. For example, because of the symmetry, due to the symmetry they have extra stability, and due to the exchange energy, if they can exchange energy more, the stability of that orbital will be more. Therefore the atoms, the electrons will undergo to give half filled or completely filled electronic configurations. So in this way the electrons are having the half filled, these are more stable, whereas this one is less stable because one is still there. So the 4s electrons move from the 4s to 3d so that it can be completely half filled to become more stable. And here 3d 4s square, only one electron is required in the 3d to get it completely filled. So 1s electron from 1s orbital will move to the 3d orbital to make it completely filled. In this way it will make it more stable. So by this the chapter has been completed.